Hello everyone, this is Shravani and I'm going to speak about operating system of Unit 2, and today's topics are scheduling algorithms and the first come first serve algorithm, which will be the part of the scheduling algorithm. So first of all, coming to the scheduling algorithm, what is the meaning of scheduling algorithms? Scheduling algorithm, it is an algorithm, okay, which algorithm are used by the different process based on the particular problem. Like suppose in memory there will be there will be different kinds of processes. So here the programmer can use or he can identify so which kind of process or for which kind of problem, so we can identify the solution or we can give the solution. So based on those solutions, we have like here five scheduling algorithms, four scheduling algorithms. So these are the four scheduling algorithms basically. Okay, so first one is first come first serve scheduling method, and second is shortest job first scheduling algorithm, and third is priority scheduling, and fourth is round robin scheduling. So these are the four different algorithms which can be implemented by the user. So based on the in the previous class or in the previous video we have discussed the scheduling criteria. So based on the scheduling criterias, okay, based on the scheduling criteria, the programmer can select any of these scheduling algorithms. Okay, and this next is either if he is having these all are off, these all can be like implemented using the single operating system. And coming to this multi-level queue scheduling algorithm, so here we can use multiple scheduling algorithms in for different queues, that also I'll be explaining, but these are different types of scheduling algorithms. Okay, so all the combination, this multi-level queue scheduling will give the combination of, in the multi-level queue scheduling there might be n number of the queues, n number of the queues where each process, different processes will be waiting in the q1, q2 and q3 and so on. Okay, and for this q1, so any one of the algorithm can be used. Like suppose consider FCFS can be used here, and for the second queue SJF algorithm can be used, and for the third queue round robin can be used, or same FCFS can be repeated again. So this is multi-level queues. Okay, I hope you all understood. And so here, as the name itself indicates, multi-level queues means so different scheduling algorithms can be used on each queue level. Okay, so and now we are going to discuss about first come first serve scheduling algorithm in this class. So here is a first come first serve scheduling algorithm. So first of all, what is first come first serve? So here all the jobs in scheduling, here all the jobs are executed on first come first serve basis. Okay, and it is easy to understand and implement. And third point is like suppose, so first of all, if the process should get executed, what happens, we have discussed in the previous videos regarding the process states. Yes or no? Yes, we have discussed about that. So initially the initial state of the process is new state. The new state is nothing but if the process or picking the process from the secondary memory and putting it into the main memory is called as new state, as we discussed earlier. And ready state is like if the process is ready to execute, whichever the process is ready to execute, that will be stored in the ready state, and whichever the process are executing and they're running the programs, they will be stored in the running state, and whichever the process are waiting for or they're performing any of the IO operations, they'll be in the under the waiting state, and whichever the process that they have finished their work, they have finished their execution of the program, they'll be terminated. This is what we have discussed, the process states. So now why I'm repeating is like because here ready state is useful. Just want to recollect the ready state. So suppose consider there are like three processes, and I want to show you the example of this only, like process P1, process P2 and process P3. Okay, they all are in ready state. They all are in ready state. Means ready state is, as I discussed, they are from new state to ready state. New state is like the operating system has picked up them. It has been picked up them from secondary memory and it has stored in new state, and from new state they're all ready to run or execute. So they all are process P1, P2, P3. They are present in the ready state. There are three processes in the ready state. Okay, now so there are already three process in the ready state. So now which process should be executing first? How do you decide? If there is only one process in the ready state, so that one process will be going to the running state. But here in the ready state, there are three processes. Now, which process to select select for execution? So at this moment, so the FCFS defines so which process should be picked for the execution. See, so before selecting the process, which process should be executed? So first of all, we should understand the burst time. Okay, process P1 has arrived at process P1 has arrived at 0. You just assume that process P1 arrived at 0 at the time, and process P2 has arrived at first time. I mean for 1 second during 1 millisecond, and process P3 has arrived during 3 milliseconds. Okay, so so first into the ready state, process P1 has arrived, and then process P2 and so on process P3. So now we'll understand what is burst time. Burst time is nothing but the process P1 wants the CPU for execution. How many milliseconds? I'm just considering it as milliseconds. So it wants 24 milliseconds of CPU. I mean 24 milliseconds time to execute the process. Okay, and next P2 requires 3 milliseconds to execute the program, and P3 also requires 3 milliseconds. Okay, so and this is the required time. Burst time is nothing but the execution time, total execution time. Okay, so this is the thing. And next coming to this, so the FCFS, what it will do, it will select the processes. It will select the processes from the ready queue based on their arrival time. Based on their arrival time. So as per this diagram, so process P1 has arrived first, and process P2 has arrived second, and process P3 has arrived third. Okay, process P3 has arrived third. Whatever the burst time might be. Whatever the burst time might be there. But this algorithm will check the arrival time of each process. Okay, so first, as the process P1 has arrived, it will pick the process P1, and this you can see this Gantt chart. With the help of this Gantt chart, we can see how the execution is going. Okay, so here, so based on the arrival time, the process P1 has got the chance for executing its program. Okay, so it has been the process P1 has arrived at 0th millisecond, and it has started executing. And what is the burst time for this process? It is 24 milliseconds. That is from 0 to 24 milliseconds of the time period. This process P1 is blocked, means it is using the memory. It is using the resources. Okay, I hope you all understood. And so after completion of this process P1, so in the queue, who is waiting in the queue? Process P2 is waiting. Okay, so even though if you check here, the process P2 has arrived at 2 milliseconds, but it has got the chance of executing its program at 24th millisecond. Okay, after completion of the P1, next then P2's execution will be started. So this will be going out of the memory, and next process P2 will be entering into the memory, and it will start its execution. So how many milliseconds it wants to execute? It wants 3 milliseconds to execute. So from it is starting point is 24 milliseconds, it has started, process P2 has started executing, and until 27 milliseconds this process P2 is totally occupied. It occupies the CPU and the memory. Okay, like all CPU, memory, and if it requires input output devices also, it can utilize this. Okay, so next comes to the next, I mean the ready queue, only one process is there, that is process P3, which is arrived at 3 milliseconds, but it is waiting still up to 27 milliseconds because it didn't get the chance to execute the to execute the program. So it is waiting, and then once the P2 is released, the next P3 will start its execution, that is it will block the it will block the CPU. Okay, so and it will complete its P3 will complete its execution within 3 milliseconds. So starting time is 27 milliseconds and ending time of P3 is 30 milliseconds. So the total overall the ending time of the I mean all the process is like starting time is from 0th milliseconds and all the process completed, all the three process completed execution at 30th millisecond. Okay, so here as you can see the waiting time for P1 is 0. Why it is 0? Because as the P1 arrived it has started executing, so the waiting time is 0, and for P2 the waiting time is 24 because it has arrived at 2 milliseconds. Even though it arrived at 2 milliseconds, but it has been waiting up to 24 milliseconds, and the waiting time for process 3 is 27 milliseconds. Okay, and the way average waiting time is like you need to consider all these waiting times and you need to sum up. So this comes here, average waiting time. So this is all about first come first serve, and the major drawback of this scheme is that the average waiting time is quite long. Why it is quite long? Because this process executes based on the first come first serve basis. So I mean whichever the process will enter into the ready queue initially or firstly, so that process will be considering. So the average waiting time based on, I mean here the waiting time is often quite long. And next, so because of this average waiting time, there might be poor performance. The performance will be degrading because this diagram itself explains the process P2 wants CPU only for 3 milliseconds, but it is waiting up to P4, but it is waiting up to the P4 P4 time until the time is arrived. It is in waiting stage. Okay, and I hope you all understood this. And in next class, I am going to discuss the next algorithm, that is SJF, shortest job first. Okay, and thank you.